Now this is engine performance test 2, at 2 test 13 and 14. All right, so let's see what we can do here. As the load on an engine increases, manifold vacuum decreases, and the manifold absolute pressure does what?
Increases.
It increases. So manifold vacuum and absolute pressure are going to be a balancing act. If you add those numbers together, you're going to get barometric pressure. If your barometric pressure is, let's say, 30, and you're going to take, if you've got 12 inches of manifold absolute pressure, you're going to have 18 inches of vacuum. See, so your MAP and your, pressure are going to be, if you add those two together, it's like a differential is what it is. If you take whatever is in the intake and subtract it from your barometric pressure, you see what I'm saying? That's how that works. So you're going to actually see these sensors that will say, they'll have vacuum displayed on your scan tool, and they'll have manifold absolute pressure. Vacuum and pressure are two sides of the same coin. A typical MAP compares the vacuum and the intake manifolds to perfect vacuum. Perfect vacuum is what it's compared to. They say which one of these statements is false, and the false statement is absolute pressure is equal to barometric pressure plus the intake manifold vacuum. So absolute pressure. So if you take barometric pressure and you add the intake manifold vacuum, you're going to be, that's all screwed up in there. See what I'm saying? If you take vacuum and MAP and add them together, you will get barometric pressure. That's a confusing thing right there. Which design of MAP sensor produces a frequency that's a digital output signal? That's a capacitor capsule. The Bronco over there, when you turn on the Bronco, if you are using a frequency, a meter that will read frequency, and you connect that to that green wire coming out of that intake, that MAP sensor on that Bronco, you're going to read about 158 hertz at sea level. If you fire the engine up, you're going to read about 100 to 110.
Bronco's cranky and it's hard to get started.
Yeah, it is. It's got dirty injectors, I think. It's been like it ever since it's been here. And I'm not too terribly worried about it. Okay, which of these is not a purpose or function of the MAP sensor? It does not measure engine speed, guys. There's no way it can, okay? It does not measure engine speed. When measuring the output signal of a manifold absolute pressure sensor on a GM vehicle, see how they like GM a whole lot? Which is fine, no problem with that. The digital multimeter should be set to read what? DC volts. You're going to read frequency on a Ford that has a MAP sensor, and typically going to read the DC volts on the other. And I will tell you, if the mass airflow sensor, if the MAP sensor is reading high altitude, then it's going to screw up your fuel trims. Now, Donnie was working on a Jeep one time, and Chrysler, I'm going to tell you, Chrysler, for the most part, has more or less, the lion's share of their history has stayed away from mass airflow, and they stayed with MAP. You might have saw that 95 neon hour, got a MAP sensor on it. See what I'm saying? But the MAP sensor, when you first turn on the key, gives the computer barometric pressure information. If it's reading high altitude, which would be, it's going to skew everything, the computer's going to go into a different set of tables, and it's going to have to add a bunch of fuel to make the oxygen sensors happy. See, because if it's making its calculations based on something that's not reality, then it's going to bend everything out of balance to try to fix what's screwed up. Donnie threw an oxygen sensor on one day on a Jeep, and I just happened to be in the shop, briefly after I came to teach here. And so he put that on, he said, let's go test drive. So I had the scan tool in my lap, he was driving a car, we drove down the road. I said, your fuel trims. See, anytime you make any kind of a repair that's got to do with fuel trims, like let's say you look at your fuel trim, let's say your fuel trims are say plus 25, right? Which means it's adding a whole lot of fuel, right? And I'm telling you, long fuel trims are plus 25, and they went there so that short fuel trims could come back to zero. All right, you're driving this thing down the road after your repair. Well, before you start to repair it, you find this problem. You say, oh, look, vacuum leak right here. Seeing this. This is split, this whole thing. So you fix that. Well, while you're fixing it, if you're smart, you'll yank the battery cable and let it forget all that fuel trim information and go back to zero, because that's what it's going to do. Now, on a Dodge, when you do that, if you don't clean the throttle body, it's probably not going to idle. It's going to have to relearn to idle. So you need to clean the throttle body while you're at it, put the battery terminal back on it, and everything's going to be at zero. Cranks it up, goes into closed from open loop into closed loop, And when it goes into closed loop, you better be watching your short fuel trim. If the short fuel trim starts going off toward McDuff's again, 10, 20, 15, all that kind of stuff, you've got something else you need to fix. Yes, you found one problem, but you didn't find them all. Well, anyway, that's what he did. He figured just from the way this thing was reading, it must be an oxygen sensor issue because he didn't find any vacuum leaks anywhere. So he popped an oxygen sensor in it. And whenever he went to, we went to drive it together, the fuel trims went right back up there. And he said, well, that's crazy. And I said, wait a minute, look at your barometric pressure. Your barometric pressure is reading a barometric pressure that's equal to like 4,000 feet. So that is not, that's why it's doing this, it's adding a bunch of extra fuel, or I mean, it's actually having to subtract fuel because it's, one way or another it's out of balance. I'm not going to beat my head against the wall. Let me think about this. If it's at high altitude, it's not going to put as much in there as it needs, right? So it's going to have to add fuel to satisfy the oxygen sensors. Oxygen sensors are going to pick up the anomaly. They're going to pick it up. If it's not putting the right amount of fuel in there, the oxygen sensors are going to say, hey, what's the matter with you? You're not sending me enough fuel. And the PCM's going to say, okay, fine, I'll crank you some more fuel in there. And it takes the short fuel trim knob and it goes click, 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 click. And if it tops that one out, it says, they say, okay, that feels a lot better. And it says, I can't leave the short fuel trim like that. That's ridiculous. So it starts turning the long fuel trim up and turning the short fuel trim back. And the long fuel trim's like your long-term learning. When the long fuel trim gets up to 25, short fuel's back at 0. And it's actually able to keep that in the middle. So always look at your long fuel trim if you're looking for a situation like that. Boy, did I ever get rabbit trailed on that one. All right, now then, which that was good stuff though. Now then,
7.
Huh?
On 7.
We're on 7? I'm always having to try to figure that out. 2 technicians are discussing MAP sensors. Technician A says the MAP sensor voltage on a GM vehicle at idle should be about 1 volt. Technician B says the MAP sensor frequency on a Ford vehicle should be about 105 to 108. Both of those guys are right. So, Technician A says MAP sensors use a 5-volt reference voltage from the PCM. Technician B says the MAP sensor voltage will be higher at idle at high altitudes compared to when the engine operating is at or near sea level. Both of those guys are right too. I couldn't see that. I might have to put on my glasses. Actually, it's because I could probably zoom in on that screen there. That's not a whole lot better. We had a fuzzy document on the screen. What's up with that? Now let's look at number 9. A manifold absolute pressure sensor is being tested. Technician A says many MAP sensors act as barometric pressure sensor when the ignition's turned off. Is that right? No, they don't. They act as a barometric pressure sensor when you turn it on, not when you turn it off. I'm talking about when you just turn on the key. Technician B says many MAP sensors, the signal voltage should increase when the vacuum at a sensor decreases, and Technician B is right about that. Okay, we're making pretty good time here. Technician A says the heavy engine load results in high intake manifold vacuum and high MAP sensor signal voltage. He is wrong as he can be. What does vacuum do when you go deep into the throttle? Drops. All right. When you let off the throttle, it comes back up. Got to understand that. Technician B says a manifold absolute pressure sensor uses a perfect vacuum in the sensor to determine what the pressure is. Technician B is the right one about that. The output of a MAP sensor is reading 1.0 volt. What is the approximate engine vacuum? 17 to 21. At 1 volt, you're looking at 17 to 21. That's healthy engine vacuum. 2 technicians are discussing MAP sensors. Technician A says the MAP sensor should be replaced if anything comes out of the sensor when the vacuum line is removed from the sensor. Now this is what's funny. You can unplug that sensor, and if jelly comes out of it, you'll know that the sensor is coming apart on the inside. The gel stuff is out there. And there was a Yoyo that worked over there with me at the Ford place. He was actually the machinist, worked back to back. He had a Ford Tempo that he had bought brand new, and he just knew something was wrong with that thing. Now this guy had as many certifications as I did, but he liked having somebody work on his car under warranty. You know what I mean? He didn't want to work on it himself. He wanted somebody else to work on it. And so he's always saying, sometimes it does this and sometimes it does that, and he drives really erratic anyway. And I got so tired of looking at that car because there wasn't nothing wrong with it. He's just a yo-yo, you know what I mean? He couldn't even describe himself, and he was a mechanic. And so one day, I just lied to him. I says, Grady, I pulled that vacuum line loose from that MAP sensor, and some jelly came out of there. And I blew that jelly out of there and put it back on. See what that does. And so he drove it. He goes, oh, man, that's a lot better. It runs a whole lot better than it did. I didn't change the daggum thing. I didn't even pull that line off of there. And I told him, I said, Grady, I lied to you. I didn't get none out of that line. What are you bothering me for? You know, you ain't got nothing wrong with your car. Get out of here and leave me alone. You know? Now I can say that because he worked with me at the dealership. He worked. I keep talking to a customer like that. You know what I'm saying? But Grady was a yo-yo. I mean, I like the guy. He built a GT40 for the boss man. He was able to do all kinds of cool stuff. Yeah, and a Cobra too. He built a Cobra too. But he's smart.
GT40.
Yeah. But anyway, okay. Let me see here. Number 13. That was just Technician A there. Technician B says the injector pulse width should increase when the vacuum to MAP sensors increase. That's backwards. P0106 DTC is being discussed. Technician A says a damaged or misfiring MAP sensor O-ring could be the cause. Missing, not misfiring. Technician B says the defective MAP sensor should be the cause, which technician is correct. That would be A and B. P0106. The P0108 is being discussed. Technician A says a damaged or missing MAP sensor O-ring could be the cause. It could be a signal circuit according to Technician B. That's Technician A. A scan tool can be used to test a MAP sensor by monitoring the injector pulse width in milliseconds while blank is applied to the MAP sensor. Vacuum. You can actually do that. A fuel injection system that does not use a sensor to measure the amount of mass airflow entering the engine is called speed density. That is a speed density fuel system. There's speed density, there's density speed, and there's mass airflow. So which sensor has a switch that controls the electric fuel pump? Oh, that's a good one. Now we're getting into some of the other VAF. How'd you know this? Huh?
Can't say.
Huh?
Can't say. I'm a genius. I just don't want nobody to know.
He just spit that answer out really quick, and now he won't tell me how you do it. That's pretty cool.
I think he guessed.
You know what a VAF sensor is? I mean, a vein airflow. Imagine this. Let's say that somebody came to you and says, we need something that instead of measuring anything else, we don't want to measure manifold absolute pressure anymore. We just want to know how much air is coming into the engine. Well, you really don't have the technology in your little workshop to build a mass airflow sensor. So what can we do? Oh, I'll tell you what we'll do. This is one of my little drawings here. Let's take a little thing right here and let's fix it so air is going through it. And let's fix it so when the air goes through it, see, we got a little vein that's hooked onto of course you got air coming out of the engine here. And this is hooked to what you would look like be a throttle position sensor, right? And it's got a little potentiometer inside that thing, and this wiper is connected to that vein. And of course it's on a different level. You see, if you looked at it like that, it would be like this with that wiper down here. All right, so the air goes through, it's going to move this flapper. Got it? The air goes through, it moves the flapper, it changes the voltage, but also there's a little reed switch right here that's actually being held open by this flapper. So as soon as air starts to flow, that flapper moves, the reed switch closes, and that drives your fuel pump. Got that? That's what it was. Everybody now knows that's something come up with by Bosch. Bosch made that, but other companies made them after Bosch came up with it. Bosch came up with all kind of cool ideas. Now they call that an air box. And they used to, we used to have to put exhaust gas analyzer on the Volkswagens, took it to a port there on the exhaust, and we had to turn a little screw on this to adjust it so the CO was at 1%. And you guys you helped me with Sean, because Sean been up all night and he's having a hard time. Yeah, Sean, did you pull an all-nighter? Yeah. All right, now then, let's see.
One of these days you're going to have a breakthrough. So one of these days you're going to have a breakthrough.
Yes. Okay. Let's see, where are we at? Which one?
18.
Okay, 18. Two technicians are discussing Karman vortex sensors. Technician A says they contain a burn-off circuit to keep them clean. Technician B says they contain a movable vane. Neither one of those guys is right about that. If you want to know more about Karman vortex sensors, read up on it in the book. They're in there. Typical mass airflow reading on a scan tool with the engine at idle speed and operating temperature is 3 to 7 grams per second. I'm going to tell you, most of the time a V6 reads about 4 grams per second. Do you remember what that Maxima was reading that you were...
Oh, God, like 20.
It was reading high, crazy reading. If it's not reading, I've actually seen them where they're just... And I'm going to tell you something. If you look at the voltage on a Ford mass airflow sensor, If it's just a tiny little bit off, it'll make the fuel trims go all over the place. Like, for instance, I had this for a long time on this Ranger. I would run out in engine performance. I'd have a mass airflow sensor that was reading .81 at idle with a warm engine, everything right. And the fuel trims would be dead on the money at 0. I had a mass airflow sensor that I got from somebody that worked on Fords that I used to work with, and I could put that on there, and look at this now, here's the difference in the voltage. We go 0.081. Got that? That's Island, excuse me, not that much. 0.81, not 0.081, I'm a dummy. All right, the one that, and it's reading, everything's nice and level, your fuel trims are all at 0, everything's great. 0.78. The sensor I would put on there for a bug would read 0.78, which is a tiny little bit. And that fuel trim would go way off because of that mass airflow reading being just a tiny little bit off.
If you look at the gram per second on there, it would be different too.
Yeah, the gram per second, this is voltage. But basically, and I was reading voltage in those days. And you can still read voltage, but gram per second is what your scan tool is always going to display. Now, some of your GM cars actually read grams per second in 4 places. They don't just read, 4.4 grams per second. They'll read they read it in thousandths, and all that. So like milligrams per second, Okay. Let's see. Also, sometimes on a GM car that's reading hertz and stuff, like sometimes they read hertz, like 150 hertz, 200 hertz, whatever. You can get one from a white box part. It looks like it was made in China or something. And when you put it on that GM car, like the older GM cars that use that kind, you may still have a check engine light. And you won't get rid of the check engine light until you put a Delco mass airflow sensor on it, because it doesn't like some of those crummy sensors. Even though the hertz may be reading normally, it just doesn't like it. Doesn't like it when the wave looks or something. All right, here we go. 2 technicians are discussing a poorly running engine with no stored diagnostic trouble codes. When the mass airflow sensor is unplugged, the engine runs better. That's an A. Technician A says, a mass airflow is supplying incorrect airflow information to PCM. He's right. Technician B says this indicates the PCM is defective. Wrong. Which airflow sensor has a dampening chamber? Now, I will tell you, wait a minute, back over a second. I have seen 2 times within the last year when the engine controller was faulty and there was no mass airflow reading whatsoever. It had the mass airflow signal shorted inside the PCM on 2 different vehicles. And whenever that's when I unplugged the mass airflow, put power and ground to it, and read the signal coming out of the mass airflow with a meter. And it would read normal.
Yeah.
Hey, Ed. And it would read absolutely normal. And whenever when I plugged it back into the PCM, that would go away. So keep that in mind too. Sometimes the PCM is bad, but you do not throw the PCM on there first and ask questions later. That is a bad way to go. And I do not remember that girl. Huh?
$200 a piece?
The PCM can cost anywhere from $200 to $2,000, depending on what kind of car it is. Put that on it.
I know you don't want to buy one for a 96 Tahoe.
What?
That's your copy.
He put, okay. All right. Yeah, no, put my copy in there.
My old Bronco did that one time. Brought junkyard gets parts. It was brand new.
Yep.
Dude put him on there, crashed his truck. 5 minutes later, parking lot hit a diesel.
Is that good?
Real good, because I got like $20, $300 part.
Neat.
I ran a PCM on a jury rig my laptop. I'd be able to sit there and control things.
That would be.
This ain't gonna be.
You'd have to think a lot faster than you're thinking after you've done an all-nighter for sure. Okay, here we go. Let me see here. It happens at Uzi speed, right? All right, now then, technician, where are we at here?
21.
21. Which airflow sensor has a dampening chamber?
Low.
A vane airflow sensor.
Boom.
A vane airflow sensor. That's B. A PO 102 DTC is being discussed. Technician A says the sensor circuit shorted to ground can be the cause. Technician B says, hey, that computer over there is one of those using.
Where can I put this at?
Huh?
Where can I put this at?
What is that?
Mulch.
Oh, put it in the refrigerator.
Where's it at though?
It's over in the corner, right over there. If you look in the corner right outside the door, that's Kayla's lunch. Keep your hands off of it. Okay. Brian Kilmeade on Fox Friends says if you grab somebody's Fanta grape or something like that and drink it out of the refrigerator, that's plausible deniability. But if you get their Tupperware bowl full of rice and beans, that is actually a violation. You know, you might think that this Fanta grape was yours, but you know that wasn't your Tupperware bowl of beans. Okay. All right. Let's see. Number technician A says mass airflow sensor actually measures the density and the amount of air flowing into the engine. Technician B says a hot wire map sensor uses the electronics in the sensor itself to heat the wire 70 degrees Celsius above the temperature of the air and come in. Both those guys are right. Basically what you got is you got two wires. One of them's a cold wire, one's a hot wire. One of them is measuring the air coming in. The other one is actually heating it up to a certain amount above the air coming in. And the amount of, what we were told in school by one of the instructors was the amount of current it takes to heat that wire up to that temperature is what it is that causes gives you your signal. But I will tell you this too, on those mass airflow sensors, if you look at them, most of the time, a lot of them, they'll have a little piece of plastic with platinum wire wrapped around it. It's really, really tiny. And if you see a bunch of crud on that, that's coming through the air filter or whatever, like little pieces of lint and oily crud and all, if you'll just wash that off, a lot of times it'll make it run real good. There's an 89 Mustang came through here. 89 is when Mustang got mass airflow. And it was running really sluggish and really bad. And all I had to do to fix that little sucker was clean the mass airflow sensor, and it ran like a race car. And I see that car every day going to, yeah.
Well, 22.
Which one, 22?
Yes.
That was a both technicians A and B. Sensor circuit shorted to ground can be a problem, or open sensor voltage supply can be a problem.
What's sensor number 23?
26, 23.
23 is also.
23. Yeah, that's both of them. Technician A says a mass airflow sensor, this is 24, is a high authority sensor and is responsible for determining the fuel needs of the engine based on the measured amount of air entering the engine. And technician B says a cold wire mass airflow sensor uses the electronics to heat a wire to 20 below. Never mind that. That's a, you're going to heat a wire to 20 below? Come on, give me a break. What are the two methods of sensing incoming engine airflow? Speed, density, and mass airflow. Got it? Speed, density, and mass airflow. PO 103 DTC, technician A says that is a sensor circuit shorted to ground. Technician B says mass airflow. Technician B. Mass airflow sensor could be the cause for that, not the other one. Let's see. PO100. Technician A says an open or short in the mass airflow circuit could be the cause. Technician B says an effective mass airflow sensor could be the cause. Both of those guys could be right about that. We're hurrying here.
Questions like this aren't going to be an ASC test, are they?
Huh?
Questions like this aren't going to be an ASC test.
If it's something that's generic that could apply to just about any car, that you don't have to have specific training, you know, they're not going to ask you. They've got particularly for advanced engine performance, they have got a generic vehicle, the wiring for it, and they've actually got a little description of how that particular one works and that kind of thing. And you've got that information in front of you while you're doing your advanced engine performance test. And that's where you get this little patch right here, that one there, that bottom one down there. But the stuff they're going to ask you is going to be just basic, across the board stuff that would apply to any car. It don't matter if you work at a Hyundai dealership or if you work at a Cadillac dealership. Those questions are going to be common sense mechanic questions that just about anybody that has any training would be able to answer. I'm telling you, if you read if you absorb the data that's in these books, you can ace an ASE test without a problem. Because these textbooks are written by people that have ASE certification and they're really sensitive to that. But some of the questions, if you ever had to write a test, you might recognize the fact that writing a test is a drag. It's really hard to do sometimes to write a test where you're not repeating yourself and all, and where it makes sense, and where the questions are not stupid. Yeah, jiggle it around. The password to get into that is going to be student, by the way.
Sorry.
We'll be through here in a minute. We only got about 3 questions left. Which of the following can be used to measure the frequency output of the sensor and compare the reading with specs?
Digital multimeter.
Which one did I skip?
28.
Did I skip 28?
We work on 28.
Oh, where is it? A digital multimeter.
It's
You're not gonna use a meg ohm meter, you're not gonna use a logic probe, you're not gonna use a high impedance test line. A vehicle runs fine when in reverse, it has a rough idle and stalls when put into drive.
Increase idle speed.
Now, what did we find, Mr. Michael Stokes, what did we find on that car?
Cracked air intake.
Cracked air intake. What happens is when the engine torques, it opens up that crack, and then it falls on its face. Sometimes you'll have, when you go to take off on one of those, it's in here and it's going, and every time it opens that air intake up, it loses power because it's sucking air in there that's not being through the.
So 30 be A also?
Yeah, and 30, yeah.
That would be B.
Yeah, it would be C.
Yep.
A or B. So you got a picture on that one, from there, of a cracked air inlet tube.
Could you take a potentiometer and get you the intake air temperature and check it to get cause more fuel?
Well, you can. I've actually heard of people doing that, but I've actually heard of people finding a resistor that was just the right one, and it would help them, with their gas mileage and all of that. I mean, you are making some mild modifications there. If you were going to do it, I guess if you were just dead set to do that and you were doing it in a research situation just for a test bed, if you had a potentiometer and you wanted to dial it up and down and compare your fuel trims and all that kind of stuff, you might be able to do
I want to do it in
something.
my race car.
Yeah, that's possible.
Give it more fuel.
Yeah, you could